So basically, in this video, we have started with our organic chemistry, for the second year, and in this case, we're talking about the nomenclature and isomer chapter. Now, as you can see in front of you, there are various types of basically family compounds of the homologous series, and we're going to see how the nomenclature is done. Then we'll be talking about various isomerisms, talking about the types of stereoisomerisms, which are the EZ isomerism and the optical isomerism, where we're talking about chirality and the formation of the optically active and the chiral center compound forming of the enantiomers. And then we'll be ending by talking about the basically the formation or the synthesis of 2-hydroxypropanoic acid, in other words, lactic acid, and the optical isomerisms application in the industry, respectively. Now, talking about these various compounds, as you can see, we're talking about the alkenes, on how the general formula and the suffix of "ene" is used, how the alkynes and was the suffix "ine" is used. For example, a propyne, the halogenoalkanes, Rx is the general formula which is used for them. Giving an example of a prefix which, they don't have a suffix. They have a prefix which is, in other words, halo, where the halo obviously being the halogens, could be either fluoro, chloro, bromo, iodo, etc. Giving an example of chloromethane. Coming on to the carboxylic acid, you see the carboxylic acid general representation is RC double bond OH. Give an example of oic acid, for example, ethanoic acid. Now, anhydrides, basically anhydride general formula is RCOOCOR dash, where R and R dash refer to the two different alkane groups attached respectively. Now, this obviously the suffix comes the anhydride, in other words, ethanoic anhydride. Now, esters, yes, esters are very, very interesting because they have the IL and then they have the O8. You see that the IL and the O8. Now, where does the IL and the O8 come from? Well, basically, in other words, if I take propyl ethanoate, propyl refers to the alcohol which is taken, for example, propanol, but the actual O8 refers to the acid, and it was the oic acid or carboxylic acid. For in other words, in this case, the ethanoate would be the ethanoic acid, respectively. Taking an example, next is our acyl chloride. The acyl chloride, if you remember, its use is which undergoes the nucleophilic reactions, respectively, with the case of the ammonia, giving the formation of our amide and the HCl gas, respectively. The HCl gas, respectively. And the example of this reaction is known as ethanol chloride oil. It was the oil compound, the actual the suffix is used respectively. Moving on to our amide, the suffix amide is used. In other words, take example of ethanamide, the nitriles, the suffix nitrile is used, ethanitrile, and the aldehydes, which are L, take example of our ethanol. And then we see the ketones, actually giving an example of our suffix of "one" for the ethanone. And talking about our alcohols, the all, or the hydroxy, prefix. There's a prefix as well, the hydroxy. For example, I can say 2-hydroxy ethanol and ethane 2-ol. Talking about our last one, which are the arenes compounds. The arenes, taking methyl benzene as an example. Now, we've talked about already the alkenes in our previous videos, and we've talked about the halogenoalkanes as well. But in this series of my videos of the organic chemistry of the second year, we're talking about carboxylic acids, anhydrous, esters, acyl chloride, and amide. These will come under the chapter of the compounds containing the nitrile groups, or in other words, the double bond O groups. Then we'll be talking about our the nitriles as well. The aldehydes and ketones will also be included in the compounds containing the nitro groups. And then we'll be talking about our arenes as well. The arenes will be included as well. And then we'll talk about the amines as well. Amines, sorry.
Rose hip.